Hello everyone, welcome to my channel Middleware Technologies. Today we are going to look at how we can use Jakarta REST API for building RESTful web services. So here in this video, we will try to understand what is REST API, and then we will try to use the Jakarta REST API in order to build our very basic RESTful web services. So let us see how we can achieve it in this video. So before getting into the implementation, let us try to understand what are the prerequisites or the test environment which we will need in order to implement this in this video. So we will need JDK software installed on our server. So I am currently having JDK 17 installed on my workstation, and we need to have Eclipse Glassfish server. So this is a very basic implementation of Jakarta EE specifications. So this server or the Glassfish application server we will be utilizing in order to deploy our application. And then we have Maven. Maven is basically used to build and deploy the project. So we will be using Maven in order to build this Jakarta REST API application. And then we have VS Code. VS Code is basically is used to develop our application. So it is optional. Like if you do not have or if you are not using it, that is fine. So for this demo, it is just we are trying to understand what exactly we need to do in order to implement RESTful web services or develop RESTful web services in our applications. So let us try to understand what exactly is RESTful web services. So every software that you take today, like let's say GitLab, Jenkins, or whatever CI/CD software that you are using, like OpenSearch. So all these softwares that the software developers are building, they are trying to provide us with a set of REST APIs which we can consume as a client. So these RESTful web services are the APIs that are provided by these software platforms. They provide us with a lightweight, loosely coupled web services which will help us in developing this REST APIs. So what exactly this statement means is, so these REST APIs that we are providing as a resources that can be consumed by the client, they are very lightweight, loosely coupled. So they do not actually need to be. So now let us try to understand what are RESTful web services. So today, if you take any software like GitLab, Jenkins, or OpenSearch, all of these software platforms that these software providers are providing to us, they aim to provide us with a REST set of APIs that we can use as an end user or that we can consume as an end user. The RESTful web services are lightweight, loosely coupled web services which help in developing these REST APIs. So let us try to understand what exactly is REST, REST, representational state transfer. So it is a architectural style of client-server application centered around transfer of representations of resources through request and resources. So let's say like you have AWS cloud, wherein we have different services running like EC2, S3, and RDS. So let's take EC2 as a service. So EC2 as a service has a list of APIs that we can consume. They provide us with APIs to create the EC2 instances, destroy the EC2 instances. We can list out the EC2 instances. So these APIs are basically providing us with the state information about the services that are deployed on the AWS. So this representational state transfer. So basically, like so let's say if you are trying to retrieve or access a REST API to list the EC2 instances. So it is going to provide us with a state of all the EC2 instances in the form of a document, and this document can be either in any format. So it can be in JSON format, XML format, or a plain text format which a client can consume. So in a REST API or in a RESTful architecture, both the client and server need to communicate with the same protocol, and they need to adhere to a set of interface or actions that can be performed and that can be supported by the application. So in REST architectural style, data and functionality are considered resources and are accessed using uniform resource identifiers. So let's say we have a class which consists of a set of functionalities, like we can list the resources, we can create resources, we can destroy resources. So these are the functionalities, and it has a set of data which is like the EC2 instances that are created that are available in the service. So these are considered as resources which we can identify using a URI or uniform resource identifier. So let's say if you want to list EC2 instances, we can identify it using /API/list EC2 instances. So something like that. So this is how we will be able to identify the resources which are REST web services, and we will be able to consume them. So as I said, the resources are represented by documents and are acted upon by using a set of simple well-defined operations. So every resource that we try to consume, it can be represented in a form of a document or which provides us with a state information about that resource, and we can either create, update this resource, create this resource, delete this resource, and everything that we do, a set of operations will provide us with a state information which we can consume as a client. So the REST architecture style is designed to use stateless communication protocol, is typically HTTP. So whatever client and servers that are going to communicate, as I said, they need to adhere to a particular protocol, and here they will be using mostly the stateless communication protocol, that is HTTP. In the REST architecture style, client and servers exchange representations of resources by using a standard interface and protocol. So as we have already learned, it uses a set of standard interface and a protocol which can be used by both the client and both the server. So both on the client side and the server side, they need to implement or use the same protocol and the same set of interfaces in order to make the RESTful Web Services communication successful. Now let us try to understand what is Jakarta REST. So Jakarta REST is basically a set of APIs, is a Java programming language APIs designed to make it easy to develop applications that use REST architecture. So what exactly Jakarta REST API provides us is, it provides us with a set of classes and interfaces and annotations that we can use in order to convert our plain old Java objects into RESTful web services. So the Jakarta REST API uses Java programming language annotations to simplify the development of RESTful web services. So as I said, developers decorate their POJOs, like Java programming language objects or classes, with these REST annotations. So these REST annotations actually tell us or define like what exactly that class is supposed to do. So we have some annotations that identify or trigger that particular class or the resource class whenever a request comes, and we have a set of annotations that carry a set of actions like get resources, list create resources, or destroy resources, or update resources based on a set of annotations that we use or decorate the resource methods. So there is resource classes and there are resource methods that we annotate with a set of annotations that are provided by the Jakarta REST in order to convert them into the RESTful web services. Now let us try to understand the high level architecture that we are trying to implement in this video. So this is the server wherein we are going to deploy application that is with the application context risk demo, and in that application that we are going to implement the RESTful web services. So we will be having a RESTful web services application context that is /API, which will provide us with a set of resources. So these are the resources that we will be trying to implement. The one is generate OTP. So this resource is going to provide us with the OTP number whenever we are going to trigger this RESTful web services API. And then we have a API in order to convert a string into the base64 format, and it will provide us with the base64 format content of that plain text string. And here like we will be looking at how we can pass the parameters as in the URI path, and we'll see like how we can consume that path parameter. And we have a great resource wherein we'll be using the similar path parameter concept, but we will try to see like how we can use different form of resource generation like plain text or HTML that can be consumed by the client. And then we have an inventory resource which basically provides us with a standard set of interface or methods or APIs we can say, which we can use in order to add, delete and update the inventory. Okay, so these are the resource methods, basically the methods in the class that we decorate with the REST API annotations, and this is the high level resource class which will take the request based on the context that is getting accessed. And this is the annotation API interface. Basically this is the interface that takes the request, and based on this get, post and delete annotations that we use or decorate the REST the resource methods, the appropriate resource gets triggered and it will process our request. And this HTTP request and response can produce data and consume data in any format. So the REST API is basically a client-server architecture wherein the request and response can be in any format. So we can define that using a set of annotations to tell like what is the client data format that the client is sending, and what is the data format that the server or the REST API resources is able to consume. So we can identify or place these annotations on the respective classes and the methods. And this is our RESTful client which actually uses the same set of interfaces and the protocol in order to communicate with the REST API web services. So this is a high-level architecture. Now let us try to go into our implementation procedure. So here, like as I said, like we need to have the following prerequisites installed. So let us jump into our shell. So I have Java JDK following version installed on my machine, so you can just have it installed on your workstation. And then I have Maven. I have the following version of Maven that is installed on my machine. Okay, now let me clear my screen. The next thing that we need to have is the Glassfish Enterprise Application Server. So you can just go ahead and download and install the Jakarta the Eclipse Glassfish server from the following location, and then this is basically a zip file or the tar file based on the operating system that you are using, and that you can just extract and set these paths basically in order to use the binaries, the ASAdmin binary in the CLI. So once you have so let me show you. So once you have installed, downloaded and extracted, like you can just do an export of your path with the location wherein the binary is available. So in my case, like I have the Glassfish server bin directory available at the following location. So I am going to just add this path to the path variable so that I can use this bin directory utilities. So I have already that in place. So once that is done, like you can just update the password for the Glassfish server admin console. So this is the admin user password that you can just update so that we can log in with these credentials whenever we are trying to access the admin console for the Glassfish application server. Now let me clear my screen. The next thing that we need to ensure is we need to start up the enterprise application server, the Glassfish enterprise application server. So I'm going to start up this service. So my Glassfish server is up and running, so you can just access it using localhost 4848 port. And you can just log in with the credentials that you have updated in the properties file. Okay, now we have access to our admin console. So I'm just going to remove the application that I have just deployed previously so that we can redo the demo. Okay, so now I have removed that application. So now we have all our prerequisites available. We have Maven, we have JDK in order to compile and build our package, and we have Maven to build our package, and we have Glassfish server wherein we can deploy our application and test it. Now let us go to our next step, that is create Jakarta EE10 minimal archive arch type project. So here, like what we are going to do is we are going to create a very minimal Maven based project based on the arch type, that is Jakarta EE10 minimal. So let us try to run this command. Let me clear my screen. So here, like, we are using Maven archetype generate in order to generate a project with the following artifact ID, archetype artifact ID that we are going to use as a template, that is Jakarta EE10 minimal, and the group ID that we are going to use for this is org eclipse starter. So this is basically a starter template project that the Maven provides us, which we can use in order to build the RESTful web services. And the archetype version is 110. This is the latest version that is available, and the group ID that we are going to use is com.stack, and the artifact ID for our application that we are going to generate, or the war file or the jar file that we are going to generate, is going to have this name. So let us try to generate this one. So this is going to create our application with the group ID com.stack, artifact ID restdemo, and let us keep the artifact version as whatever is defined, the default, and let us keep the package as com.stack.restdemo, and let us generate this project. So the project has been built or generated, so we can just go to rest demo folder and look at the tree structure. So this is how the project gets generated. So we have a pom.xml, and we have source main Java, and this is our package com.stack demo, wherein we are provided with the base class, and these are the resources that we are going to update or modify in order to build our RESTful services. So let me open this project in VS Code to do our development activity. So now let me go to my procedure. So like we have seen, like we have generated the project, and we have seen the project structure. This is the project structure. Now let us go to our next step, that is step 3, update the application context route. So basically, like, what we are going to do here is, so we are trying to build RESTful web services, and these RESTful web services, we can provide a base path to our resources using using annotation. So that annotation is @application path annotation. So the application path annotation is used to define the URL mapping for the application. The path specified by the @application path is the base URI for all the resource URIs. So this is going to act as a base URI for all the resource APIs or REST APIs that we are going to define in our RESTful Web Services application. So all the resource URIs which will provide us with API endpoints will have this @path annotation, and the base URI is going to be defined as or the class that is going to be our base resource is going to be defined with the @application path annotation. So for the application path annotation to be applied, that class needs to be a subclass of Jakarta Web Services REST core application. So let us update our application config file, which is basically a subclass of application. So let us see. So here, if you go to source main Java application config file, so this is basically a class that extends the application. So it is basically a subclass of application. It is provided with Jakarta Web Services REST core. Okay, so here, like, we can update our application path to /API. So this is going to be our entry point to all the API resources that we are going to build. So let me save this. So we have updated our application path annotation with the following endpoint. Now let us go to our step 4. Here, we are going to create a REST API resource to generate the OTP. So let us try to first copy this code, and we will try to understand what exactly we are doing. So here, I'm going to create a generate OTP Java file in the resource folder. So this is the folder that we are going to use in order to create our. So let me increase my font size. So here, we are going to create a file generate otp.java. So now, what we need to do is we need to convert this class or to this plain old Java class into a web service. So how we are going to do this? So first of all, we need to annotate this class with the path annotation. Basically, in order to use this annotation, we need to first import these classes or interfaces, we can say, annotations. So here, I'm going to use this path annotation that I have just imported over here, that is available in Jakarta Web Services REST services path. Okay, so once we have annotated the class, the next thing that we are going to do is we are just going to copy this content. So this is basically going to generate the OTP, that is a 6-digit random number. So we are actually using random functionality. We are importing a class and we are trying to use that in order to generate a OTP number and convert it into a string and return it as a response. Okay, so here there are few important things that we need to understand. So the first is add path annotation. So this is going to define our API URI. So basically, whenever a request comes to /API/generate OTP, it is going to trigger this generate OTP class to retrieve the do the processing and generate the response. Now, what exactly we want to do? We want to get an OTP. So for in order to trigger the get request, we need to have a method that is public string generate OTP annotated with the @get annotation, so that whenever a get request or a get HTTP request is triggered on this path, we are going to trigger this resource method, and this is going to basically generate our OTP and return as a string. And here, you can see, we have used the @produces annotation. So this basically defines what type of response is produced by this method or the resource method. So here you can see the media type is text string. So this is basically equivalent to text/plain. So basically we are saying this method produces a plain text response. So now we have our generate OTP method created and ready. Now let us go to our next step, that is step 5. Here, what we are going to do is we are going to create REST API resource to convert a string to base64 format. So let us try to understand about this by copying this class, generating this Java class. So let me first create this resource. Close this one. So here we are going to create base converter.java file, and let me copy all this content. And we will try to understand what exactly we are doing over here. Okay, so we have base converter class which will get the request. So whenever there is a REST API triggered with the following path, and the following data is provided in the path. So this is going to be our path parameter that we need to consume. Okay, so now we have understood about the path annotation. So it basically triggers the appropriate REST the resource class to take the request, and then we have the get annotation that basically triggers the appropriate method based on the action that we are trying to perform. And then we have looked at the produce. Basically it produces a response in the form of plain text, and here you can see we are just doing using the base64 utility or the class in order to generate our base64 format of the plain string. So this is the data. So basically how we are mapping the path parameter to the parameter that we have defined in the method. So what we need to do is we need to use this path param annotation in order to use the parameter that we have passed in the URI, that is identified with the alias data, and that is going to be that value is going to be stored in this parameter that is going to be passed to this method. So once that value is available, it will convert that value into the base64 format. So this is what the basic base64 format string converter looks like. So we have looked at the path parameter annotation in this. Now let us go to our next step, that is step 6. Create a REST API resources to greet user. So this is going to be again same resource, similar kind of a resource I can say. So let me create this greet user.java resource, and here let us copy this content. So basically we are going to trigger this greet user class, resource class, whenever a request comes with the /users/username context. So once we have /users/bob, let's say that is a request that we have triggered, this resource class gets triggered, and this is going to accept the get request. This is the method or the resource method that we can say that is going to take the request, and it is going to consume that path parameter that we have passed, and it is going to supply that as a parameter to this method, and then it is going to generate this HTML response. So the only difference from this generate OTP class and the base64 converter.java resource class is the produce type. So here we are generating the text plane, and in the greet user we are producing a response in the HTML format. So that is the only difference that we have done in this resource. We are generating the response in the form of HTML. Now let us go to our next step, that is step 7. Create REST API resources to manage inventory. So this is going to be a bit more complicated, we can say, wherein we are going to use different annotations for different actions that we are going to perform. So let us see like what are those. Okay, so here like we are going to create a inventory.java file in the resource folder. Let me recreate this one. Okay, so now we have the inventory.java file created, and let me copy this whole content. Now let us try to understand about this. So this is our inventory class. This is a resource class, we can say, which will get triggered when there is a /inventory request is requested, and then we are using a static collection. Basically this is used to store some kind of inventory elements, we can say. So here like we are using this collection in order to store our data or the inventory products, we can say. Okay, and now comes the important thing, that is methods or the actions that we are going to trigger. So here like we are defining three methods. One is add products, that is going to take a product item and it is going to add it to the collection and return the response as product added successfully. And here like we are basically what we are doing is we are passing some data in the post request. So here it is going to be the post request. So for that we need to annotate this method with add post. So whenever there is a post request is coming for this API, it is going to trigger this method and it is going to generate this text plain response, and it is going to consume this text plain response as a data. So we will see it in action when we are going to validate the APIs. And now let us go to our next method, that is get product. So let's say like we have added some set of methods that we want to list them. So here like we are going to use the get product in order to get the list of items that are available in the collection in the form of text plain. So it produces a response in the text plain and it accepts the get method. So this is the path that we need to trigger, and this is the annotation which basically triggers this method whenever there is a get request coming for this API. Now we have the final method, that is delete product. So once we have a collection of items, so let's say if you want to delete a particular item, we need to trigger, we can pass that using the following path parameter. So we have this delete path with the path parameter passed, and it produces a plain text output and response. So here we are going to pass this path parameter into this product, and if let's say if the product is null or product is empty, so if we are not defining if we are not sending any product, that we need to remove it from the collection, and the response is going to be product cannot be null or empty. So we are just using this response object to build the response with the following content. So this is, we are not getting into the details of the code, but this is what the implementation is exactly. Okay, now let's say the product, the collection product has been passed, and we are removing it using this method. When the remove is successful, it will be true, removed will be true, and it will provide a response with the product has been removed successfully. So this is going to be the response that is going to be returned to this request. If the product is not removed, let's say if we have passed a product which is not available, so the response is going to be not found entity. Okay, this is how the implementation of the web services are done based on the annotations which define the actions and which define the path of the URI path basically for the resource. So now that we have created all our classes or the resources, we can say, now it's time to get into some action. So let us go into our next step, that is step 8. So here, like, what we need to do is the generated form.xml is not ready to deploy the code to the Glassfish server that we have available on our workstation. So what we need to do is we need to update our form.xml with some configuration. So let us see what that configuration is. So the first thing is we need to update our form.xml property files with the Glassfish home path wherein our Glassfish server is available. So this is first thing that we need to do. And then we need to update the plugin. This is the plugin that we are going to use in order to automatically deploy the artifact, the WAR file that we are going to generate for this application to the Glassfish server. So let me copy this. So this is the whole plugin section that I am going to add. So let me take this whole plugin section and let me copy it into the plugin section. So this is the plugin that we are going to add. org code has cargo, and this is basically going to deploy the project. So whenever let's say if you are going to do an integration test, that it is going to deploy the project and test it. And the configuration that we have is, this is the configuration. The container ID should be Glassfish 7, type installed at the following location, and so we are going to use the default Glassfish server implementation which has a domain 1 created in the domains folder. So this is what the configuration should be looking like in order to deploy the code into the Glassfish server. So that is the only change that we need to do. Now let us go to the next step, that is build and deploy the application. So now we are going to do maven build. So let me see, like, open the terminal and let me expand it a bit and let me copy the command. So here, like, what we are going to do is we are going to do maven clean. If there are any build already done, it will clean that, it will rebuild the package, and it will deploy. This task is going to deploy the package, that is the WAR file, to the Glassfish application server. So let us trigger this one. So now you can see the WAR file has been created. It is available at the following location. So rest demo targets. So it is going to create a targets folder, and there the WAR file will be available. And then we are going to use the cargo deploy in order to deploy our application to the Glassfish server. So resolved container artifact for container. Glassfish, it has identified the Glassfish version that is available or ready, and it has deployed the code into that server. So now you can just go to the Glassfish admin console and you can see the application REST demo has been deployed. Okay, so you can launch it from here also, but let's not do it from here. So I'll show you like how we can do that using the VS Code. So let me close this one. Let me minimize this. So if you have curl, you can use that one on your machine. So let me go to, so now we have completed our build and deploy step. So the next step, that is step 10, is validating the REST APIs. So here, like, we are going to first, let's say, let's use curl in order to consume our REST APIs. So first, let us try to consume our default API that we get, that is this one. So we are triggering the GET request, which accepts the content type text plain, and the API that we are trying to access is, so this is our application context, and this is our REST API context, and this is the resource that we have already available or created when we generated the Maven project. So let us see that class resource also. So this is the resource. This basically this is a resource. So whenever there is a path request get request comes to this path, it is going to generate this hello from Jakarta EE message. Okay, so this is the standard template generated code which we haven't done anything with. So let us try to trigger this, and you can see the response has been created. Okay, so now you can use curl, that is fine, but let's say if you are on operating system where curl is not installed and you just have a VS Code. So what we can do is we can install a REST client. So you can just do REST, search for REST, and you can just install this REST client. And now, like, what we are going to do is we are going to create a .http file wherein we can define our HTTP requests or the REST API request and trigger it from the VS Code itself. So let me copy this file I have already available in my backup. I'll just copy this to the current location. So this is our HTTP file looks like. So let me just put let me just create a get hello request. So what we need to do is we need to just do get, and the API path that we have triggered, we need to copy that, and here, like, we can just say it accepts text plain and content type text plain, and let us try to trigger this. So now, so we are getting an error. So basically, it means that it is not able to generate. Basically, if we look at the REST resource for this, so let me close this one. Let me close this response. So if you see, it produces a response type of JSON, application JSON, rather than a plain text. So that is why, like, whenever we are sending this accept as text plain, it is not accepting that response because it is not actually a plain text response. So that is why, like, you are getting that error that is 406 not acceptable. So it is not able to accept that response. So what we will do is either we can remove this line, accept line, or we can just do application /JSON so that it will accept that JSON response. So this is how you can test your APIs using the REST client that is available in the VS Code. So now we have tested our hello API, that is the default one that we get. Now let us go to our next API, that is the OTP generator. So here we are going to trigger this generate OTP API. So we need to do this comment and get OTP in order to separate this request from this request. And now let us do get, and here we are going to copy. So this is going to generate text plain content type, and it is going to accept the text plain. So we are going to pass the following headers. Okay, so now let us try to send this request. So you see the OTP number has been generated. So let us try to trigger. You see the OTP number is changing. So this is a very basic API that we have developed, REST API, wherein we are sending a GET request to the resource, that is generate OTP, that is going to trigger the resource class method, that is generate OTP, and it is going to provide us with the OTP number. Now let us go to our next API, that is REST API for base64 encoder. So here there is one important thing that I wanted to mention over here, generate OTP. So here we have generate OTP path that will trigger this GET request, and it will generate the OTP. So let's try to test it first. Okay, so let's try to test this API. No, we have already tested the OTP generators. The one that we are trying to look at is base64 converter. Okay, so this is the thing that we wanted to test, which will convert our plaintext string into base64 format. So for that, the context is going to be this. So let me go to the HTTP file, and let us try to create another request, that is get base64 format of string. And here this is also going to generate a text plain and accept we are going to pass text plain data, and we are going to accept text plain response. And here I'm going to send this data to base64 encoder, and the data that we are going to send is hello space world, hello comma space world, and %2c and percentage 20 are the URL encoded values that we need to provide instead of the characters. Okay, so now let us try to generate this one, and you can see the base64 encoded output has been generated. So now we have just did generate base64 format, but let us try to modify this code base64 converter with the following content. So this is basically the same code, but we have modified it in such a way that we have two methods, that is encode and decode. So the encode method takes data at the following path, and it is going to convert our plaintext string to base64 format, and the decode path parameter, the decode method is going to decode our base64 format string into the plain text. So what we have modified is basically it is going to accept this path parameter, and whenever there is a slash encode slash data request is coming, it is going to trigger this get method and return the base64 format. And whenever there is a slash decode slash base64 data is provided, it is going to trigger this response, which is going to be a plain text. So this is how the very basic change that we can do. So we have we can say a root resource. Underneath we have sub resources which we are going to trigger. Okay, so now what as we have changed the code, like we need to redeploy the application. So let's try to do a redeployment. So first of all, we need to do maven cargo undeploy, so that we undeploy that application, and now we can do a clean package and redeploy. Maven clean package cargo deploy. So now we have redeployed our application. So now let us try to use that new feature that we have just updated. So let me copy this, and now we are going to update this request context to base64 converter encode, and this is the data that we want to encode, and let us send this. And we have triggered that encode slash data method. Now let us take this same request to decode our content. So they get decode format of base64. So here let me get that string, base64 string, and we are going to pass that in this decode path. So we are not doing anything, we are just doing decode base64 string we are passing, so that whenever this path request gets triggered, it is going to trigger this from base64 format method, resource method. So now let us see like what is our plain text data. So this is our plain text data that we have converted into base64 format and again to plain text. So now we have tested our base64 encoder and decoder. Now let us try to look at the greet user API. So for that we are going to copy this, and let us try to create another get request. Let me copy this first and get greet user, and let me copy this again. So here like we are going to do a get request on the resource users slash, this is the path parameter that we are passing, and it is going to generate what kind of response. So let me look at the greet users. So it is generating a text HTML, so the accept should be text HTML. Content type that we are passing is the plain text, so that should be fine. So you can see the response is HTML, that is hello Bob. you can do anything. So it will update and provide you with the response. Now let us look at our final REST API, that is a complex one, that is a manage inventory, wherein we have different actions like add, delete, and what we have is and get. So let us try to use that one. So for that, like I already have that in available over here. So here in the inventory, first we need to add some data to our collection. So this is the API endpoint that we are going to trigger in order to add some data. So this is the collection item that we want to add. So let us see, like we are adding Python to our collection. Python product has been added successfully. Let us try to add Java. Java has been added successfully. So these are all post requests, wherein we are triggering this post API endpoint and providing the request file. Now let us add the third item, that is Ruby has been added. So now the thing that we are going to check is get the collection item. So we are going to trigger this API inventory get, which is going to provide us with a list of collection items. And now let us look at the final action that we are going to do is delete. So we are going to do a delete of an item from the collection, that is Ruby. So we are going to pass this as a path parameter, and we are going to remove it from the collection in the code. And let us see, Ruby has been removed successfully. So now we should ideally have Python and Java in our collection items list. So now let us do a get request again on the inventory API inventory get, and we will see Python Java. So this is how like you can build your own REST APIs using the Jakarta REST API annotations that are provided, which we can apply it onto our plain text, old Java objects. So this is all I wanted to show you in this demo. I hope you enjoyed watching this video. Thank you all. Thanks for watching this video, and you guys have a great day.